Nintendo won't publish an N64 game for you. So how did I get this? This is Junkrunner 64, an open world game I made that runs on original N64 hardware. You can see how I rendered the open world in my last video. Enough of you asked for physical copies of the game, so I went ahead and got some made. You can check the link in the description to get one yourself.
You can also buy this t-shirt. It's supposed to be kind of like a riff on Lambert and Nintendo, but I don't know if that comes across. I was trying to avoid lawyers by not making it too close, but now it says Lambert. I still kind of like it. If you want one, pick it up.
So what goes into making a cartridge like this? To answer that, let's take a look inside an original N64 cartridge. You can see there are 3 chips on this cartridge. So what did I do? Well, let's start with this big one right here. That is the ROM chip. It's where the game is stored. Naturally, this chip uses the most pins because it needs to be able to transfer data the fastest. The N64 has a 32-bit address space for reading from the cartridge. So in theory, cartridges could be up to 4 gigabytes. They send data back 16 bits at a time. So that's a total of 48 bits, but there clearly are not 48 pins on that chip. So what's going on here? Well, there's a 16-bit bus that is used to both send and receive addresses and data between the cartridge and the console. And these 4 pins control the timing and the direction of the data on that bus. This 16-bit bus and those 4 supporting pins make up the PI or parallel interface. And it works like this. Here's the timing diagram for how that works. Let me explain how you should read this diagram. The top shows 4 different lanes. The top 2 lanes are 1-bit signals for the address line high and low. The bottom lane is a 1-bit read pin. 1-bit signals like these can be shown directly as either high or low. The last lane in the middle is the 16-bit wide bus. Since it represents 16 different bits, you can't actually show that all in the timing diagram. Instead, these crossover points where they make an X indicate that the 16 bits change to something, but the spaces between the X's signal that that value stays the same. I will add a hex number to the timing diagram to indicate the value being passed on the bus as I walk through it. Let's start at the beginning of the diagram. All the 1-bit pins start high and the bus is undefined. The first thing the N64 does is write that first 16 bits of the address to the bus, indicated by this first X here. After that, the address line high is set low. This indicates to the cartridge that the bus contains the upper 16 bits of the address, and the cartridge stores that data away. Next, the N64 writes the lower 16 bits to the bus, then the address line low is set low. This signals to the cartridge to store the lower 16 bits. After that, the cartridge is ready to send data. The N64 pulses this read pin here to get the data. So, every time the pin goes from high to low, the cartridge will write out the 16 bits at the given address, and then increment that address by 2. The N64 can now read that value off the bus and store it into the RAM. If the console sets the read pin high then low again, the data in the next consecutive address is sent back. You can repeat this process multiple times. This allows the console to quickly read consecutive memory addresses without needing to resend the address. So that is the ROM chip. But what about this little chip here? Well, that is the EEPROM chip, which is used to store save file data. The only data pin used to communicate with the EEPROM is this pink line here. These other 2 are a clock and a reset signal. That kind of sounds like another device on the N64 that uses a single data pin to read and write data, the controller. And turns out they both use the Joybus protocol to do that. And the same piece of hardware that's used to talk to controllers is also talking to that EEPROM chip on the cartridge. If you want to learn more about the Joybus protocol, you can go watch this other video I made where I talk about it in more detail. And the little piece of hardware that actually does the communication with Joybus, it's called the PIF, and we'll talk more about it when we get to the copyright protection. Not all cartridges use EEPROM for storage. This one here, it doesn't have any storage on it. And well, this one right here has a few more chips, but this has SRAM. This SRAM chip, doesn't have a single pin like EEPROM. Instead, it's connected to the PI or parallel interface the same way the ROM is. How did the 2 chips not interfere with each other if they're on the same bus? Well, each chip is assigned a different range of addresses and they only respond to their address range. So for example, the ROM chip has this address range and the RAM will stay quiet if you ask for something on that range. And well, the SRAM has this range And so when you request ranges at that address, the ROM chip stays quiet. And the parallel interface could also be used to write data to the chip. It works very similar to how reading works. It's just that the console is sending the values on the bus instead of the cartridge. And when the data is available on the bus, you pulse the write pin instead of the read pin. So that's saving data. Lastly, there is this chip, the CIC chip. This chip is used to verify that a cartridge is not a pirated clone and is officially from Nintendo. Upon boot, the CIC chip on the cartridge and the PIF chip on the N64 do some secret handshake to determine that it's actually legit. If it's not, then the N64 resets itself. The PIF chip also performs the important function of communicating with controllers, as we discussed before. This makes it so you can't just mod your console by removing the chip and have it continue to function. This poses a problem for me because I want to make Nintendo 64 games, and Nintendo, they're not going to be sharing any CIC chips with me. Even if they wanted to, they probably don't even have them anymore. This is true with all of the chips on the ROM. They all have these proprietary Nintendo protocols. I can't buy some off-the-shelf component to make these cartridges. So what do I do here? Fortunately, other people have figured out the protocols to get these to work, and there are companies that let you make your own cartridges for the N64. This one's made by RetroStage, which I highly recommend them. They're not sponsoring this video. They make more than just N64 cartridges. Check out their website, it's pretty cool. All right, let's take a look inside one of these to see what's going on. The pins used to send and receive the ROM data all connect to this chip here. And well, this isn't a ROM chip. The ROM chip is over here. No, this is an FPGA. It solves the problem of Nintendo's proprietary protocols. So you can basically write and program custom hardware to this chip. The address logic, the Joybus protocol, and even the CIC logout chip can be programmed to it. The save data and ROM still need to be stored on separate chips here, but the FPGA becomes a central hub that communicates with the modern storage chips in the console, tricking the console into thinking it's playing a genuine N64 game. I skipped something important here, the CIC chip. See, you can't clone something if you don't know how it works. And the CIC chip is meant to be secretive. It's their copy protection. They don't want anybody to duplicate that. So how did that get figured out? Thanks to Mike Ryan and John McMaster, we now know the secret handshake. And the story's pretty cool. First, they just tried to listen in on the handshake and see if they could figure out what they were doing from there. But it just looked like random data every time. And it was different every time. They couldn't find any patterns. So there's no luck there. And so they eventually had to resort to dissolving the plastic off of one of the microchips and removing some of the top layers of the silicone so they could actually see the transistors under a microscope and from that derive the algorithm. Pretty crazy. I'm just blown away they managed to do this. If you're interested in that process and what they did there, check out this video. They talk about it in great detail. It's a great watch if you're interested in that kind of thing. Put all of that together and now you can make cartridges that are outside of Nintendo's control. Unfortunately, this means now there are fake cartridges on the market trying to sell themselves as real to trick you into spending a lot of money on something that's not a genuine N64 product. Knowing what to look for on these cartridges help you spot fakes. A real Nintendo 64 game is going to have that CIC chip on it, and it'll just say written on it, CIC Nintendo. If you see that, probably real. If you see an FPGA on it, it's fake. I originally wasn't planning on making more physical cartridges of Junkrunner. I was just going to do a few for giveaway and a few for the team. But enough of you asked for a copy that I did it. The team made some improvements to the game too. The indoor locations have been polished. There's music where it was missing before. There's some bugs fixed and some gameplay improvements. You could still download the game for free if you want. It's just right here, but you'll need a flash cart to run that. I'm making a limited number and I don't know when I'll have a chance to make more, so if you're interested, be sure to pick one up. A lot of you are asking, do you need the memory expansion pack to run this game? And kinda. It's highly recommended because there are some visual improvements that border on necessary in order to play the game with a good experience. So I wouldn't buy it if you don't have the memory expansion pack. But hey, the game also works on analog 3D and mod retro, so if you don't have an N64, you can buy one of those and you can play the game. Making these physical cartridges was a little bit of a test run for my game I'm working on right now, where you can craft your own spells. It's gonna be kind of Zelda-like, but I want to add a unique flavor to it with this spell casting system. You use the C buttons to cast spells in real time, which you can use to defeat enemies and solve puzzles as you crawl through dungeons, but the overworld is going to be a big open world like Junkrunner. That was also kind of one of the things I want to do, was test out that as an option for this game. I'm really excited about this project. If you're interested in it, please subscribe. And I'm really grateful to anybody who supports it, either by watching this channel, liking, or even joining as a Patreon member. I'm hoping that when this game is done, I can add another N64 game to the library that feels like it belongs there. Thank you all for watching, and until next time, take care.